Hi Lindsey, Professor Sebastian here, just trying to give you some feedback on your Precalc exam 2 and also just talk to you a little bit about the final here at the beginning. I'll just take care of this business at first. So notice that before I reviewed your exam, you had a 66.67%. After reviewing it and finding more partial credit due to your work, good job. We got you at 83.57, which seems to be a much better representation of what you know and how you're doing. And I took a look at your overall grade right now and noticed that your overall percentage grade is 85.57. So you're solid in the solid B, really B plus-ish range. So really doing well. Keep working hard. I mean, there's no reason you can't get yourself up into that A minus A range if you push through and do well on this final exam. So try to learn. So final exam, what do you need to do? 50% of the final exam will come straight off exams 1 and 2. So that means that you really want to study those and the feedback I provide to you with these videos and the feedback on your work. And then the other 50%, 25% will come from the quiz 5 from week 5 that we're finishing up right now. And then the other 25% will come from the week 16 2 homework assignments. So yes, it's backloaded on the end. The last 2 weeks of the course has 50%. The first 4 weeks is 50%. But it is cumulative, so you need to understand all the things you got from exams 1 and 2, quiz 5, and the last 2 homeworks in week 16. Okay, so as far as the second exam, let's go through this and get you some feedback. So in this first problem, when you have a rational function, you want to identify what the domain is. The only thing, these are both polynomials, so the only thing you have to worry about is the denominator cannot be 0. So notice that x squared is always positive or 0. So x squared plus 8 can never be 0. It's always positive. So there is no issue. Everything, any x you plug in here will be fine. So there is no restrictions on the domain. It would be minus infinity to infinity. In question 2, we have a similar type situation, except they want you to identify wholes and asymptotes. So you did a good job factoring the denominator, and you notice that x minus 5's cancel. So that means that where the denominator would be 0 at x equals 5 is actually a hole in the graph. The function doesn't exist there because it's not in the domain, but there's just a hole in the graph there. Whereas the problem at x equals 2 that makes the denominator 0, that cannot be canceled with a factor in the numerator, so that is an asymptote. So there's an asymptote at x equals 2 and a hole at x equals 5. I think you've put the hole at x equals 5 correctly, but you didn't even mention the asymptote at x equals 2. So just be careful, you just missed the asymptote. Question 3. Here we wanted to find the horizontal asymptote. So as long as the numerator's highest power and the denominator's highest power are the same, you do have a horizontal asymptote, and it's the ratio of the coefficients. So it should be y equals minus 3/7. I'm not sure what you were doing. Look like you were saying the denominator equal to 0. That's not what we're looking for. Okay, that would be a vertical asymptote. We're looking for a horizontal asymptote. So the horizontal asymptote is y equals minus 3/7. Yes, you put in the vertical asymptote. Okay, question 4 you had correct on my math lab already. Question 5. We have a inequality equation we want to solve. So you did a good job. You factored. So then you want to think of these as two numbers being multiplied, right? X times 5x plus 9 has to be positive. That means that they either both have to be positive. So that's case 1 I wrote here. X has to be positive and 5x plus 9 has to be positive. You solve that through. You see that x has to be greater than 0 and x has to be greater than minus 9/5. So the most restrictive case there is x has to be greater than 0. Or they could both be negative numbers, so x is less than 0 and 5x plus 9 is less than 0, which means that x is less than negative 9/5. So the most restrictive number there is x has to be less than negative 9/5. So the domain would be minus infinity to minus 9/5, not including, and union 0 to infinity. Okay, so that takes into account both accounts there. Question 6. Again, we have an inequality equation here. Now it's a greater than or equal to sign. But again, you were just looking at where the denominator is 0, and that's not what we're trying to figure out here. We're trying to solve this. So think of this as a fraction. So if I have a fraction that's positive, that means both the numerator and the denominator have to be positive. Now the numerator could be 0 because it says or equal to 0. Or both the numerator and denominator have to be negative. And again, the numerator could be 0, so that's less than or equal to. So you solve both of those. You see that in this case where they both have to be positive, you get that x has to be less than or equal to 4 from this equation, but x has to be greater than 7. You can't have both less than or equal to 4 and greater than 7, so that's not possible. And in the case where they're both negative or 0 in the numerator, you get that x has to be greater than or equal to 4 and x has to be less than 7, so now we have a solution set. Okay, so 7, 8, and 9 you had correct on your own through my math lab. Question 10. Log base 3 of 27 equals y. So you have it correct here. That means that 27 equals 3 to the y. Excuse me. And you even said, hey, that means y equals 3. So, and that's your answer, is that 27 equals 3 to the y is what you should have put in here. So it wasn't even asking for the solution to what y is. It was just looking for this exponential form. So again, I think it was more of just, and this would not be right. Y does not equal 3 to the 27th power. Okay, so it's 3 to the y equals 27. All right. 11, 12, 13, you have correct on your own. 14, 15, 16, you have correct on your own. So 17, let's see what we have here. 17, it looked like you had the right idea. Take the natural log of both sides when you have exponents with x's in them. That brings the exponents down. So now that's quantity 2x plus 5 times natural log of 2 equals quantity x minus 3 times natural log of 5. Now this is an algebraic equation to just solve for x. So I wasn't sure what you were doing here because you're dropping the natural log and all that stuff. So natural log of 2 and natural log of 5 are just numbers. So you have to solve this for x. So I actually worked that out for here on the last page, right? Because you actually put something here on the last page too. But again, you weren't solving this correctly. So when you get to this point, then I would distribute the natural log 2 through. So you get 2x natural log 2 plus 5 natural log 2. Distribute the natural log of 5 here. X natural log of 5 minus 3 natural log of 5. Put all the terms with x on the left side. All the terms without x on the right side. Factor out the x. Divide by what you factored out. And you have the answer. And you can plug it in your calculator to get. So it's algebra about solving. Knowing to use the natural log was great. But you now have to solve it using algebra. Okay, so that's 17. Let's go back here. Okay, so let's see, 18. Next problem. Here, I actually, when you're solving this equation, what you have to do is on the right-hand side is bring these two logarithms together first. So yes, this would be the log of 7 times x plus 3. When you add two logs, that's how you would bring them together. So then the log of something equals the log of something else, which means 6x minus 9 equals 7 times x plus 3. So good. So you end up getting a solution for x, but here's the problem. You have to also look back. So that is not your solution. You can't just plug that in, because when you look back at the equation, the original equation, and you plug in x equals minus 30, notice that has us taking the log of negative numbers. That's not allowed. So the log of negative numbers does not exist. That means there is no solution here. All right, 19, 20, 21, those are all correct on your own. 22, 23, correct on your own. 24. 24 wants you to find a positive angle that's less than 2 pi that is coterminal with 25 pi over 3. So yes, you had the right idea. Subtract 2 pi, which is the same as 6 pi over 3 to get 19 pi over 3, but that's not less than 2 pi. 2 pi would be 6 pi over 3, right? So 19 pi over 3 is not less than 2 pi. You just have to keep subtracting 2 pi. So I showed you that on here. Just keep subtracting 2 pi until you get to a coterminal angle that is less than 2 pi, which is less than 6 pi over 3, so you get pi over 3. All right, that's 24. Let's see, 25, 26, 27, 28. You had it correct on your own. 29, a little bit off. So let's see on 29. So you have the right idea. Cosine of 64 degrees equals b divided by 293. So b would be 293 times the cosine of 64 degrees, which is correct. What I noticed your answer, you just had your answer had to be in your calculator must have been in radians mode, but notice we want the cosine of 64 degrees. I checked to see if it was in radians mode, and that's what you would have got if you left it in radians mode. So you got to put your calculator in degree mode to be able to do the cosine of 64 degrees. You always got to know what mode you're in when you're doing trig functions, okay? So either degrees or radians. So this is degrees in this case. So you're just a little off that way, but because you had it was about calculator being in the wrong mode, it gave you almost full credit there. And then that's it. That's your feedback on exam 2. All right, Lindsay, keep up the good work. If you have any questions, don't hesitate to reach out. Bye.